When I was a child, I was always curious why mechanical watches can work without batteries. What is its power source? And how does it achieve the timing function? In this video, let's learn about the working principle of a mechanical watch. First, the power source of a mechanical watch is the mainspring. It is made of a steel sheet curled. When it is wound tightly, it stores elastic potential energy and releases it slowly, providing power to the mechanical watch. The spring is placed in the spring box. One end is connected to the winding gear, and the other end is connected to the barrel. The small gear above is independent of the spring and rotation, the connected ratchet and pawl assembly, allowing the small gear to rotate in only one direction, thus preventing the spring from loosening, and ensures that the power of the spring can only be outputted. There are two ways to wind the spring. The first is to manually rotate the crown. The crown is engaged by sliding. Engages the small gear and the winding gear. When the crown is in the default position, rotating the crown can tighten the spring. Later, people had to wind the spring every day or two, which was too troublesome. An automatic winding rotor device was invented. Take this double direction winding rotor as an example. When people wear the watch and move, due to the force of gravity, the large circular pendulum will swing. The pendulum drives two pendulums to move back and forth, which apply thrust and tension to the escape gear, respectively. This makes the escape gear can only rotate in one direction. The escape gear meshes with the mainspring gear, can continuously wind the mainspring. Nowadays, most mechanical watches use automatic winding movements, but in some high-end products, still insist on using the more ceremonial manual winding movement. It is worth mentioning that most automatic mechanical watches also retain the function of manual winding through the crown. Hey, the crown also has another function, which is to adjust time. When the crown is pulled outward, the setting lever engages the second groove and drives the sliding gear to move forward, separating it from the upper gear set, and connect to the time setting gear. At this time, rotating the crown can make the minute and hour hands rotate. The power released by the spring drives the transmission wheel set. The center wheel is directly connected to the spring, which rotates once per hour, which also drives the minute hand on the center wheel to rotate at the same speed. This is the movement mechanism. It allows the hour and minute hands to rotate freely to achieve the purpose of time setting. On the other hand, it also slows down the hour hand speed to slow down the rotation speed of the hour hand so that the hour hand on the center wheel can rotate once every 12 hours. When the power flows out from the small gear of the hollow shaft, flows through the minute wheel, this deceleration can be achieved. The third gear of the transmission wheel set is responsible for transmitting power to the fourth wheel and amplifies the speed. Thus, the fourth wheel rotates at 1 revolution per minute, and then drive the second hand on the fourth wheel to rotate at the same speed. Each gear is located on a gem-made bearing. These gemstones can significantly reduce friction between structures, so that the mechanical device of the watch can operate smoothly for decades. Next is the core of a mechanical watch, the escapement and balance wheel. Imagine if the energy in the spring be directly released to the transmission wheel set, it would be uncontrollable. To make the wheels move regularly, we need to limit the speed of power release. This is the role of escapement and balance wheel. It can make the power in the spring and evenly release when the fourth wheel transmits power to the escapement. The escapement wheel drives the balance wheel through the escapement fork. Due to the limitation of the balance spring, prevents it from rotating continuously, but instead it will do a periodic reciprocating motion. This way, the balance wheel limits the rotation speed, thereby limiting the release speed of power in the spring, making the entire system operate regularly. Let's take a detailed look at this process. Beilong Chongsho hits the escapement fork, causing the other end of the escapement fork to move backward, and then releases the escapement wheel locked by the pallet. At this time, the special-shaped escapement wheel, teeth, will transfer the power to Beilong Chongshao through the escapement fork, allowing Beilong to enter another swing. Meanwhile, the other side of the escapement fork will lock the escapement wheel until the Beilong punch and hits the escapement fork again. The cycle continues, achieving a regular periodic motion. The balance spring can be adjusted by adjusting the pin to adjust the tension, which changes the swing frequency of the balance, thereby adjusting the speed of the watch. The unique ticking sound of a watch is emitted when the escapement pin jewel engages the escapement wheel. Each rotation of the escapement wheel is called a beat. The beat frequency of an ordinary watch is 21,600 times per hour, which is 6 times per second. That is to say, every 600 rotations of the escapement, it will drive the second hand to rotate once. In 1795, Master Louis Breguet also invented the tourbillon mechanism. He installed the escapement mechanism and balance wheel on the tourbillon frame. The frame rotates once a minute to offset the error caused by gravity, the error caused by the escapement system. Although the tourbillon is not as important as the pocket watch era, its complex mechanical structure fascinates people. This also makes the tourbillon become a symbol of high-end mechanical watches.